Welcome to Encryption for Apps based on AWS Solutions Architect topics by AWS. We offer microservice introductions, exam question explanations, and practicing of real exams. Encryption for your app means having a plan. Think first about all requirements such as public or confidential classified data, regulations, and the constraints for required end-to-end encryption or already existing protection measures. Based on it, you clarify the strategy for encryption at rest and in transit. Make a choice to encrypt at rest on the client or server side. Client-side encrypts data at its source app to ensure a highly secure but costly end-to-end encryption, often in a limited controlled hybrid model. In contrast, server-side encrypts at its destination app with high control to ensure correct implementation. Most AWS services offer a default automatic server-side encryption with the integrated AWS Key Management Service, called KMS. It securely manages and authorizes the keys, and in the attached hardware security module, called HSM, you store the keys. Which protection do you want for your in-transit traffic? For your apps, you can use public or private certificate protection on each endpoint. With public transport layer security certificates, called TLS, you enable secure internet browsing. This provides identity trust and protection against man-in-the-middle attackers. In contrast, the private issued and distributed certificates encrypt traffic for VPN users, IoT devices, and apps with confidentiality. Both can be established individually or automatically with the scaling AWS Certificate Manager, called ACM, to secure, store, and to frequent rotate certificates. Hold on a minute. If you like this channel and its content, please subscribe it on the right bottom button. With growing interests, we will continuously improve the freely available content for further courses. Now let's continue. Encrypting at rest is following the keys. Most solutions use a mix of client and server-side encryption, realized with KMS and HMS service. And on-premises apps can securely be integrated with the software development kit, called SDK. For any at-rest encryption in the AWS cloud, you get the default KMS key stored in HMS. To actually encrypt a plain text, your EC2 app requests a data key and its encrypted copy. KMS returns then the plain and the encrypted data key. With the SDK algorithm, you now encrypt the plain text into the ciphertext. This file and the encrypted data key is finally stored in S3 storage and the plain data key is deleted. The same process takes place for on-premises plain text file. The main CMK key is also available in the AWS cloud, but you kick off encryption with the plain and the encrypted data key. Finally, the encrypted data key together with the ciphertext file gets stored in S3 storage. Secure your app's in-transit traffic with ACM certificates. They are integrated with the internet-facing ALB load balancer, CloudFront, or the API gateway for a secure HTTPS connection at the endpoints. This services can also terminate the certificates in the backend to save costs and time. To fully manage all certificates, ACM provides scaled issuance, rotation, and storage. Then you define with ACM and the ALB the use of a public or private certificate at each EC2 endpoint. Like this, you architect your app's data and communication security with the AWS encryption services. If you want to prepare and safely pass the AWS Solutions Architect Associate exam, we recommend to also practice our real exams on Udemy. We wish you further insights with AWS videos.